Let's look at sampling and do a brief statistics review. I know you all had statistics at some point in the past, but it may have been many years ago, and you may have forgotten everything you ever learned. The learning outcomes include: we'll define basic statistics with your population, element, sample, and subject. We'll evaluate some issues associated with sampling. And we'll look at how you might determine sample size, or how someone might consider it. So let's quickly revisit statistics. You've got the population. That's the entire group you're interested in learning about. Let's say we wanted to learn about KSU students. It's a 32,000 large group of very diverse people, undergraduates, graduates, and non-degree seeking. Each person from that population is an element. From the population, you draw a sample, a smaller group. You want to have a representative sample, so you want to have some undergraduates, some graduates from all the different colleges, some traditional age, some non-traditional age, freshmen, sophomores, juniors, seniors, graduate students, and doctorate students. From the sample, each person is a subject. So looking at the overall picture, you have an overall population. For many reasons, you can't survey the entire population. They won't all respond, even if you ask them nicely to. Some of them will drop out, others will come into school as you're gathering the sample. So each person in the population is an element. From the population, you draw a smaller sample that's representative with approximate characteristics of the whole population. And each person in the sample is a subject. With sampling, you wonder, why don't you draw the whole population? As I said, you simply can't get them all to respond. Even the census, which is required to be the entire population, has trouble getting everyone to respond. The time it takes to gather the data, during that time, people die, people are born, people leave the country, people come into the country. You have to try to measure homeless people who are notoriously difficult to find and categorize as living in a particular area. There are many things. People may not be home when you come by. They may not want to talk to you. So drawing the whole population is difficult, even for a relatively small group of 32,000 at Kennesaw State, as opposed to 360 million or so that are in the United States. You do want it to be a representative sample with about the same number of males and females, about the same number of different ages, different ethnicities, different majors, different years in school. You want it to be about a normal distribution, so you don't want to find a whole lot of outliers, for instance. Like graduate students are very different from undergrads, and they make up a smaller proportion of the total. If you remember the normal distribution, that's the little bell curve. Most of the time we want to find a representative sample so the average remains the same. We don't want to get on the outliers and get, as I mentioned, a lot of graduate students or a lot of older or younger or different kinds of students than is representative of the whole. So you want, as you draw each sample, this would be sample A, B, C, D, E, etc. You would assume that over time all those samples together would have the same average as the population as a whole. Even though F is a little off, if you see it's a little off to the right, over time all the different samples are around the average, around the mean. types of samples that you might have, a probability, which means everybody in the population has an equal chance of being selected as a sample, as part of the sample. Non-probability, you may ask for volunteers. You don't really know how many will respond or what types, so it's not a probabilistic sample. A convenience sample is a non-probability. Convenience samples are those that you gather because they happen to be there. A group meets in a building, you ask them to take your survey because they're there. They're convenient. Convenient sample would be like you going to a business. They thanks for doing business. What did you think of our service? Well, they're asking only those people who came to the store, only those people who agreed to be sampled. It's a convenient sample. They may really want to ask those people who didn't come to the store. Why didn't you come to our store? When you're trying to decide how big your sample should be, there's a trade-off between precision and confidence. Precision is how close you are to where you should be, but if you have a confidence interval, the larger the interval is, the less precise you are. So if I say tomorrow the temperature will be 55 degrees, I'm probably going to be wrong, but I was very precise. If I say it's going to be 55 plus or minus 5, that means 50 to 60 degrees, and all of a sudden I'm pretty confident of what I said, but I wasn't very precise. So confidence is how sure are we, precision is how close we are to what it actually is. Usually in academic studies, they use a 95% level of confidence, which will be a p-value of 0.05 or lower. Even at that, if you're 95% confident, you're still wrong 5 times out of 100. So you need to keep that in mind as you're looking at the results. You could be wrong. So there's a trade-off between confidence and precision. Some rules of thumb for determining sample size. Samples of 30 to 500 are usually appropriate. Not very helpful, but you don't want it to be too small. As it gets too big, the resources required to gather it will probably mean that the time goes by and it's no longer an accurate representation. With subsamples, undergraduates and graduate students, for instance, you want to have at least 30 respondents, 30 subjects for each category. If you have several variables or things that you're interested in, you want to have 10 times the number of variables at a minimum. So if you're studying 5 issues, you need at least 50 responses. These heuristics vary widely, and you have to make an argument for why your sample was valid. Qualitative samples have generally smaller sample sizes than do quantitative. Qualitative has richer data. Quantitative has more respondents at the cost of the richer data. So with qualitative sample studies, it's typically only practical to have small sample sizes. You then impact your external generalizability. If I only talk to 5 different managers, I'm not sure how applicable that might be to many other situations. But I'm pretty confident that I've gathered rich data about those 5 types or 5 similar organizations. So your internal validity is high, your external validity not as high. This is open-ended items as opposed to multiple choice items. To summarize, we looked at the different statistics terms. You're going to see sample and subject or respondent most often. You need to make sure you have a representative sample, and you need to question the representativeness of studies of samples from studies that you read. The researcher should describe how the sample was selected and why it is representative. many rules of thumb for determining sample size, none really better than the other. You have to get a feel for the data, some practice, and make an argument that your sample is representative and allows you to make interpretations about the population that interests you.